Hello and welcome to this workshop on how to use the 3D modeling software Fusion360. So this software is fairly simple to use and relies on a very simple basic concept. And the basic idea is you can create two-dimensional sketches, which you can add thickness to create three-dimensional objects, and then you can repeat that process over and over to get complex objects. So the way that one would get started in this program is first we need to look at the user interface. So as we can see, we have this cube here, which lets us navigate around our model. And also you can just click on certain surfaces to align to standard positions. Uh, at the bottom, we have an orbit tool, which lets us do the same thing. We have a pan tool, which lets us move side to side our model. And then we have zoom tools. You can fit your model in a certain range, which won't work because I don't have anything yet. You have display settings. You can like put artificial environments around, which I'm not going to do right now. And a bunch of things. You can just explore these menu options. You'll see the different things. And then over here we have a browser where we have our other files stored. So you could just double click on them to open, and we'll explore that later. And then over here we have our in model menu. So when we do something in our model, any sort of changes will appear down here. And over here we'll have a list of all the objects we have in our 3D model. So to start, what you want to do is to create a two-dimensional sketch, which would be in the Create tab. Actually, I should finish going over the menu first. So over here we have the Create tab where you can create different objects. Normally we'll be using the Create Sketch thing to create a two-dimensional sketch from which we'll create an object. Then there's the Modification tab, which allows you to make changes to already existing models that you've created. The Assembling tab, which lets you put models together. And then the Construction tab, which lets you place various tools to help you. So if I turn on this, and we can see these different planes here that we can see. Using the Construction tab, I can generate, let's say I want a plane that's a certain distance away from this plane, and I have a new plane, which I'm not going to save because I don't actually want that. But you can do a bunch of different things so you have reference points to use in your models through the construction tab. Then there's the inspection tab, which lets you measure distances and a bunch of different things. The most important one here, I would say, is section analysis, which, as you can see, has a little pop-up that explains how it works. So once you have a 3D model, you can click on a face, and you can basically see a cross-section of the model, and you can move the cross-section to see how things interact on the inside of your models. And then you can insert images and stuff like that, and yeah. So what we're going to start out doing is by creating a two-dimensional sketch, because let's start with something simple. Let's make a cube. So we can choose which plane we want to draw it on. I'm going to choose this one. And as you can see, I have a menu that has popped up here. And this has a bunch of different modes that lets me do things like enable snap to grid and stuff like that. I can disable my sketch grid, and so on. And what I'm going to do is I'm going to go to the Create menu where I have all these different objects, which I can choose from for my 3D model. So I'm going to start with a rectangle because that's the easiest way to make a square. And as you can see, we have three different options. I'm just going to click center rectangle because that is the easiest to use. What you do is you click a center point, and then you can move your mouse to another vertex to get your actual object. But as you notice, when I stop moving, these text boxes appear, so I can set certain distances. So let's say I want to make my my square 69 by 69 by 69. So I will type in 69. I will press tab to get to the other box. I'll make that one also 69 millimeters, and I have a 69 by 69 square. So now that I have my square, I can basically add thickness to it using the extrude tool, which we can't see right now because we are in the sketch menu. But if we look, it's completely flat. There's no three-dimensionalness to it. One other thing I should mention is with these tools, any of them, you can create a thing called a construction line, which are these dotted lines, which are basically for your reference and do not actually show up as part of your model. So if I create a line that is not a construction line, we'll see that it'll actually create a split in our model. So by the way, L is the hotkey for lines, R for rectangles, C for circles, and there's some other hotkeys for other common shapes. So I'm going to create a line here. And as you can see, it split our model into two sections. And as you can see, the construction lines do not. And the useful thing with this is you can have certain shapes. Let's draw another rectangle like that. And then one more like this. Let's say I want all of these to be the same and be in the same orientation. What I can do is I can say that I want this face to be parallel to this face using a constraint, and there are a bunch of different constraints, and then I can say I want this length to be equal to this length, and then I want this length to be equal to this length, and then this length should be equal to this length, and then this one to this one, and we have 3 identical squares. But the most important thing about this is if I change the initial dimension from, let's say, 69 to 42, all of the constrained dimensions get rescaled. And this is very useful, because let's say you wanted to create some shape for your project, and it was something like this. But you didn't really know how big you wanted it to be, but you knew that you wanted this section and this section to be of equal length. Oops. Uh, uh, Actually, no. Let's say you wanted this angle to be perpendicular to this angle, and this angle perpendicular to this one, and then you wanted the length of this one to be equal to this one. What you could do then is you could say, all right, I know what size my model is now. What I want to do now is I want to uh, basically say that this length should be 50 millimeters, and it'll rescale all of your constrained models, so it's very useful. Okay, so now let's get back to our simple cube. We can either press Finish Sketch, or we can press E to enter extrusion mode. And what you can see is I can select all these objects. So I'm just going to select our cube, and I will make it 69 millimeters tall. As you can see, our sketch was automatically hidden, and hidden in our menu we have our body, which is our cube, and our sketch, which is currently hidden, but I can show again. One thing I forgot to mention in the extrusion menu is every menu, such as rectangles, so on, extrusions, revolutions, fillets, so on, they have a little menu here, and here you can change what you're actually doing. So, with an extrusion, you have some options. You can just extrude from the sketch. You can extrude offset by a certain distance. You can then say offset from an object. Then you can, so let's just do offset just for demonstration. I can make it 20 millimeters, and it'll raise the object by 20 millimeters. Then you can choose directions. You can do 2 sides. You have different distances in both directions, or you can have a symmetric extrusion or a simple one-sided one. And then the most important tool is the operation tool. So currently it's set to new body, which makes sense. We have no bodies within our model. But what we see here is we have a join, cut, intersect, and new body option. The join thing, if we had 2 models next to each other that intersected, it would make them one model, basically just joining at the boundary that they have. Cutting would cut through any intersections. Intersect would leave only the intersection section, and new body is just a new body. So let's leave it for now, and we have a cube. So now I'd like you to pause the video and make sure that you are able to create the basic cube. Now, assuming that you've been able to create the cube, what you can now do with this cube is you can do various modifications. So, as you can see in the modification menu, we have shells, which basically let us make a shell through our object. Or we have fillets, which let us curve the edges, which, I mean, usually not functional. There are some functional applications of it, but it mostly just looks pretty. There are chamfers, which are same thing except it's flat, which is actually better for 3D printing because curves are not great with FDM 3D printing. And then there's splitting and so on. The majority of these things you can figure out for, just by playing around. So just do split face. I want to split that face. Sorry, I want to split the body. Split this body using the origin plane. Let's just make the body invisible so I can see it. I want to split it by that plane. Now I have 2 bodies, each of them halves. And let's say I didn't want to do that. I have this timeline down here where I can go back in time, I can delete what I did, or I could just do Command Z, or I could use the join function to rejoin them. There are plenty of ways to undo what you do. So, yeah. So after making a cube, you're wondering, so like, what if I want to add some screw holes to it? So you'll see there's this hole tool, which isn't actually that great because it doesn't really like control where you put the hole. It just kind of plops it wherever you click, and it's not very dimensionally accurate. But one thing that's nice is like you can just quickly add a hole. I want it to be 10 millimeters wide, deep, and 10 millimeters wide. And then you can like have a chamfer at the bottom and so on. Uh, it's it's kind of nice. And then what you can do is you can create a thread to thread your screw into. Always remember to click the model button, otherwise it won't actually make your thread. And then you can choose standard thread sizes and pitches and everything. And yay, we have a hole to screw stuff in. And that's the simple way to do it. But what I'd much rather do is create a new sketch where I can make dimensionally accurate things. So let's make a sketch on this face. And let's say we want 4 mounting holes that are on the center lines from the axes, and we want them to all be the same size. So what we can do is we can create a construction line like this and like this. And then we want them to be, so we can measure this distance. It's 48.7. So we want each uh, thing to be, let's say, 6 millimeters away from the edge. So we can do 48.7 minus 6, and that'll give us a shorter line. And then what we can do is we can use the circular pattern tool where we take this and we select the center point and we create 4 of these, and then we can create a circle. Actually, I could have created the circle beforehand, and let's make the circle 4 millimeters in diameter and use the pattern tool again, and we have our 4 mounting holes, which we can then take and extrude down into the object. Or if we want, we could make them stick out. So that's the basics of how to create an object in Fusion 360. Alright, now that we've gone over the basics of how to create a 3D model in Fusion 360, you may want to take some time and explore the different modification tools that are available to you and so on. But another thing that we could look into is how to create more organic models and shapes. So, because as you can see, just building and like sketching things on the sides of objects, it's not very easy to get organic objects. I mean, you can get somewhat close with some sort of approximation. You can have something like this, and you can use a chamfer to make it look kind of organic, but you can't. There are something you're limited. You can't really make very organic objects this way. So another approach would be, instead of using extrusions, you can make a two-dimensional sketch. Let's try making a vase. You can make a two-dimensional sketch where you basically do a cross-section of a portion of it around an axis. And what I'm going to do here is I'm going to use the spline tool, which lets me make a curved line, and then regular straight line, and we have this structure. And if I attempt to extrude it, we'll run into a certain issue. The fact that it's not really a vase, it's more of a, I don't know, sort of wedge with a curvy shape. But what we can do instead of extruding it is we can use the revolving feature, where we select the profile and then we select the axis, which is the vertical line which we drew, and it gives us a circle. And the circle is, I don't know, more of a bowl than a vase, I'm not sure. It's close enough. But as you can see, it's not a very useful vase considering it's completely solid. So what we can then do is we can take the shell tool and we can give it a thickness of 4 millimeters per se. And now we have a vase. But one thing you may notice is these edges are super thin. They're not realistic. You're never going to be able to manufacture this. This is when tools like the fillet come in. You can, make it more realistic. Just, there you go. And that way you're not cutting your hands on infinitely thin edges with your 3D model. So yeah, that's the basics of how to make a model. So one thing you may have noticed in our bodies menu is if I right click on a body, I have this menu that it has more stuff. But if I click on it in this menu, if I click on it here, I have a couple tabs. So I can export the file as an STL file, which for 3D printing is useful, but we'll get to exporting later. What we can see is an appearance and a physical material menu. The appearance menu just lets you change the color. It's kind of useless because I mean, it's just visual. It's not really important, but I guess it's important if you use the render tool, which by the way lets you create like cool images of your object. Let's say you want to like show off a product, you can create cool images. It requires a lot of computing power and takes a while. If you have a powerful computer, you can do it on your own, but normally you'll use Fusion360 Cloud credits, which if you have an education account are free for you. If you don't, uh, then you need to pay for them. So I'd rather not do that. But I do have an education account, so I can request a render, it'll be high resolution, and yeah, it'll look much better than the one that my computer produced, but my computer can make some pretty good quick images. But that's what the appearance tool is for, but it's quite useless from an engineering perspective. What the important tool is the material tool. Because what we can do is we can set different actual materials. So the standard material is steel. But let's say we're 3D printing this. It's going to be plastic. So let's just make this ABS plastic. And that'll come in handy later. So currently it still looks like glass because I did not change the appearance settings to be plastic. Because if I hadn't changed the appearance setting, it would have automatically changed the plastic, but since I changed the appearance setting, it's using the previous one. So let me just fix that. There we go. It's made of plastic and it looks like plastic. Let me just verify that. Yes, it is made of plastic. Okay, so with this, when we actually do simulations, which I'll get into in a minute, it's very useful. But first, what I want to go over is the assembly function. So if I try to make a joint and I click on the bodies, it says there are no components available. And the reason for this is when you're working on large assembly like a robot, the idea is that you can import models from different files. And in order to be able to distinguish subsections of an object, and the actual like object itself, there's a distinction between components and bodies. So what I can do is I can create a component which is just my vase, or I can make a component which is both of our bodies. But I'm just gonna make one that's just the vase, and then I'm gonna make one that's just the body as well. And then I'm also gonna import um, another model, which just so happens to be my previous attempt at recording this because I may or may not have had some issues with that. But what I can do with these components now is I can use the assembly feature and I can create joints. So what I can do is I can click on, let's just hide the cube, it's annoying, the center of this one and the center of this one. And what you can see is it moved them together and made a sort of rigid joint. So what a rigid joint is basically if I move these, they'll move together. This is just me changing the offset of the joint, so it's not demonstrating it properly, but if I press OK, they'll be fixed together, they won't be able to move. But what the important thing is you can simulate how like a robotic arm will move, because you have different motions, so you can create a revolving joint, which is quite hard to see because this phase is symmetrical. Let's make it revolve in a different axis. You see? It's revolving. Y-axis, yeah. And then you can make sliding joints, cylindrical joints, pin slot joints, planar joints, ball joints, and so on. There are a bunch of different joints you can try making. This is useful because let's say you want to simulate your robot's movements, just make sure nothing intersects when it's moving, you can do that. And you can also enable contact so that it'll warn you if any objects are hitting each other and intersecting when they're moving around. So that's, and then also you can do a motion study, which lets you basically select your joint. I only have one joint right now. And you can set different positions to it. So I just make it 30 degrees. And then I can basically play this video. And since it's spinning around the axis, you can't really see, but actually I can edit joint. There we go. And then I'll do drive joints again. Motion study, I mean. And we want this joint, 69 millimeters. And then over here, 420 millimeters. And then over here, 0 millimeters. And if I play this through, we'll see that it moves away, it moves super fast, and it comes back. And this can be used to create all sort of animations of how your object will move. And you can add several joints, and you can have them running in parallel. Let's see, can I add the joint from my previous example? Yes, I can. And this one I want to go minus 30 degree, minus 40 degrees. Yeah, all right, sure. This is good enough. And let's just play this through. As you can see, the cube is rotating and so on. Yeah. Okay, so now that we've seen how to create some 3D model objects, I'm going to give you a challenge. Try to create a coffee mug. So pause the video now and come back when you're done. Okay, so now I'm assuming you've done it. I will quickly create a coffee mug as well, just to show you how I would have done it. So what I'm going to do is I'm going to create a circle. So circle, let's make it 80 millimeters, and I'm going to add some thickness to it, make it 4, add another circle on top, which will give me my inner and outer walls. Let's make this 76 millimeters, add some thickness. That looks like about the right proportions. And then we have basically a mug, but you obviously need a handle. So what I'm going to do is I'm going to create a sketch. And the sketch will be very simple and crude. We have a handle. Let's move this up. I don't like that. There we go. And then the inside of the handle. Oops. Whatever. I can just trim that off. And as you can see, it's not a very nice handle. It's very sharp. So what we can do is we can use the fillet tool, make it nice, easy to hold. There we go. And now we just need to add some thickness, which might seem simple at first glance, but we'll clearly see that there's a little bit of an issue here. Oh, one thing I forgot to mention is sketches should always be enclosed if you want to make a body out of them. So as you can see, this is an open face, so I just gotta close that, and the other one too, at which point I can create the model. Okay, so the issue that you'll notice here is that this model will actually be tangent to the cup. It's cutting because I didn't quite make it straight, but in theory, if we look at the bottom, it's tangent. It's not actually connecting to the cup. And the way to solve this is to use the, what is it? The sweep along a path tool. So what I'm going to do is I'm going to take this face, and I'm going to set the path to be the top rim of the cup, and change it to join. Now we have a handle all around, except this handle is useless because, well, you can't get your hands inside of it. So what we're going to do is we're going to change the distance. So instead of being 1 revolution, set it to 0.005, 0.03. That looks about right. And then it still has some sharp edges, so let's add some fillets. Um, uh, it's a bit much. That is interesting. Let's try that again. 6 millimeter. Nope. 3, 4. Sometimes with fillets you have to experiment. Like it might glitch out a bit. Just try changing the numbers to something smaller. Okay, let's make these also 4 millimeters. And now we have a nice handle. But let's make the cup a bit nicer. So what we can do is we can add some fillets. Got a nice rounded base. Did I just... Yeah, that's something that you might notice. We just poked a hole in the bottom of our cup, and there's a fairly simple way to fix this. What we can do is we can go back in time, and we can either add more thickness to our base, or we can add a similar fillet on the inside, so that our fillet on the outside does not actually cut through our walls. So see, the cup is whole again, and let's just add a chamfer for diversity on the top. Actually, it's not a huge fan of the chamfer, but there we go, 2 millimeter chamfer, and then let's fill at the edge of the chamfer, because why not? And we have a mug. Yay. So hopefully your mug turned out something similar to this, or maybe even better, who knows, this was fairly rushed. So now we'll go back to our vase model and look at some simulations. So this is useful for creating all sorts of assemblies. But you might wonder, what was the simulation stuff I was talking about earlier? So what you can do with an object like this is, let's say we want to see what would happen to this in the event that a moving ball hit it really fast. So let's create a ball. Yeah, capture position, and let's make it right here. There we go, 70 millimeters. Move it up. Sorry, I just want to put it in a good position. And let's go to the simulation feature. So what one can do in the simulation feature is actually quite a few things. So you'll see this menu. So you can perform a simulation of static stress where you just say, here's gravity, here's some forces on the object. You can see how much it'll deform based on the materials you selected and so on. You can see like how how electronics emit heat, how you can see how heat flows through your object. You can see how thermal expansion will affect your object, thermal stress, structural buckling, and event simulations and shape optimization. Shape optimization is really interesting because what you can do is you can create a solid rectangle, and say you're making a shelf, and you say there's going to be 10 pounds of force on the top of the shelf, and it's going to be mounted on this wall. Remove all the unnecessary material. And you give it a target, let's say I want 20% of the initial mass, and it'll analyze where the majority of the weight is being held up, and then it'll remove sections based on your criteria for how much lighter it should be. It'll remove the least useful sections. But what I'm going to demonstrate is an event simulation. So what one can do is one can press the create button, at which point you'll be brought into this menu. So let's or okay, that's going to be in the way. One moment. Design. Let's just delete this component for a moment. Okay. A simulation. Why is that component still there? I see. There we go. Okay. So what we want to do is, let's say this steel ball, first we'll enable gravity. Then let's say that this steel ball is moving with a velocity of 100 meters per second in that direction. Which, is that pointing upwards or downwards? Upwards, okay. And minus 100 meters per second here. And we're interested to see how this plastic bowl will deform when being hit by a ball moving at a ridiculous velocity. So what we can do is we can say, this bowl is magically glued to this other bowl, which magically cannot move anywhere. So this face can't move. And then we can enable contact, so anything that's close to it, anything that's touching another object, they'll all be merged together into one object for the simulation. And then, let's see, what else do we want? We can also simplify the geometry to make the simulation run faster, so I can just select you. Actually, yeah, we don't need to simplify for this. Yeah, so just make sure that you have no errors, so generate contacts. Okay. Oh, you can ignore that. Let's just simulate it. So the same thing as rendering, simulations cost cloud credits. As I have a student license, I have infinite cloud credits. To make sure you get infinite cloud credits, if you're a student, just make sure you sign up for Fusion360 and your Autodesk account through the Fusion360 student activation window. You just say what school you're from and give them your email, and they'll verify you, and then you'll get it for free. If you're a hobbyist, you can't really use these features unless you're willing to pay for them. And you might notice that you can do some simulations locally, but stuff like event simulations, like impacts, you cannot do locally. You're required to do them on their servers. So we can start the simulation, and we'll see what happens. And one thing to warn you about is simulations do actually take quite some time. So I'm going to cut the video here and come back when it's done. Okay, so I said I would do the simulation of the vase, but I ran into some issues with the fact that I had a bunch of joints from different files, and as you add more things, you may have some weird bugs appear. So what I decided to do instead was a more simple demonstration. I have a steel plate and a steel ball. The ball is moving at 100 meters per second. At the steel plate is fixed at its bottom. And I did a simulation, and what we can see from the simulation is, as the steel ball gets closer to the plate, you can see the ball passes its energy to the plate, and the plate begins to deform on impact. So as we can see, at the beginning, the middle of the plate moves outwards, and then as we continue scrubbing forward, we see that the plate begins to flex and the ball begins to bounce back. So this simulation was only a tiny fraction of a second because of the high speed. So in theory, we'd see the ball shoot off in the other direction, but the simulation was shortened just to reduce the computational load. So using this, you can design different objects to withstand different impacts, and it's a very useful tool. And it's just the very basics how to use it. And you should just play around with it if you have a student license, which gives you infinite cloud credits, just see what kind of cool and interesting things you can do. Um, so thank you for coming to this workshop on how to use Fusion 360. If you have any questions, I believe my email will be provided. Um, Good luck and have a good life.